Hello everyone and welcome back. My name is Mr. Kovold, and in this video I'm going to go over how to balance chemical equations by going over these examples. So let's get into this. So I'm going to balance the equations. Most of the time I'm going to balance the equations by working methodically through the elements. The procedure that I use, the steps that I use is first I would balance the metals before nonmetals. And then once all the metals are balanced, I'm going to balance the nonmetals. And then when I balance the nonmetals, I'm usually going to balance everything except for hydrogen and oxygen. And then when I have oxygen and hydrogen left, I'll usually leave oxygen to last and balance the hydrogen first before oxygen. Now, there's a couple of other things to keep in mind is if I have an element that is by itself as not part of a compound, I'm going to leave that element for last and balance it after I've balanced everything else. Okay, that's something to keep in mind. A lot of times that will be oxygen, but sometimes it'll be nitrogen or some other element. Um, the second thing to keep in mind is that another strategy you might want to use sometimes is if you have an element on one side of your periodic table that's just by itself, and you have that element as part of a compound, you can use the subscript of the element and write it as a coefficient to the compound on the right hand side, your product side, and then use the subscript of the element in the compound on the product side and write that as a coefficient for the element on the reactant side, and then continue from there to balance the other elements. Okay, so that might be a strategy to use as well, and I might show that here if it's applicable. The other thing to keep in mind is that if you have you're balancing the equation, you can use fractions to help you balance the equation. That'll usually come in very handy when you balance your last element and that element is by itself, not part of a compound. And so you could use a fraction with the element and then get rid of the fraction by multiplying the equation by a factor that's going to get rid of the fraction, but at the same time you're going to keep the equation balanced the way it is. And oh, excuse me. The other thing to keep in mind is that if you have polyatomic ions in your formulas and they don't come apart, they stay together on the left and right hand side, then you can treat that as one unit. You don't have to break it up and count each individual atom and make sure that they balance. You can just count it as a unit in and of itself. So let's go ahead and show how this is done. So in part A, you'll notice I have phosphorus reacting with chlorine to give me PCl3. And so I'm going to balance the phosphorus. But what I can do first is I can balance the chlorine on here by switching, oops. Sorry about that. So I can switch the subscripts and the coefficient. So I can write the coefficient of one of my element here, and I can take the subscript and write it as a coefficient over here. So I can take this 2, write it as a coefficient there, and then take this 3 and write it as a coefficient there. That way I'm guaranteed that the chlorines are going to be balanced because here I have 3 times 2, and here I have 2 times 3, which is 6. They're both 6, so now I've balanced the chlorines. And now I have this element by itself that I can balance using a fraction in this case. So here I have 2 phosphorus atoms. So 2 times 1 is 2. I multiply the coefficient by the subscript to get the total number of atoms of that element. And so here we don't write the ones, but it's there. So 2 times 1 is 2. And then here I have 1 times 4 is 4. So I have 4 on this side, and I have 2 on this side. So I want to have less on this side. So what can I do to make this 2? So I can multiply by 1/2. So I can take a 1/2 here, right? So now 1/2 times 4 is 2. So now it's balanced. So I have 2 phosphorus atoms on this side. I have 2 on this side. So that is technically balanced, but in balanced equations, we don't want fractions as coefficients. So we got to get rid of the fraction. So to get rid of the half, I can multiply this by 2 to get rid of the half. But if I multiply this by 2, then I have to multiply everything by 2 in order to keep it balanced. Because right now it's balanced. If I just multiply this by 2, then it's not going to be balanced. So I got to multiply everything by the same factor. So I multiply 1/2 by 2, and that's going to give me 1. So we don't write the 1, so that's just going to stay like that. And then 2 times 3 is 6. So I'm going to put a 6 here. And then 2 times 2 is 4. So I'm going to put a 4 here. And then you double check to make sure everything's balanced. So 4 phosphorus, 4 times 1 gives me 4 phosphorus. 6 times 2 is 12 chlorine. 4 times 3 is 12 chlorine. So everything is balanced. Let's go to the next one. So here I have this equation here. So you'll see right away that I have nitrogen by itself. It's not part of a compound here. So I'm going to save nitrogen for last. I'm going to balance nitrogen last. I'm going to balance everything first. Again, I'm going to start with metals and then balance nonmetals. So here I have 1 lead atom. 1 times 1 is 1. And here I have 1 lead atom. 1 times 1 is 1. So that's already balanced. I don't have to do anything with the lead. So next, now it's the nonmetals. I'm going to keep nitrogen for last. And so I have oxygen and hydrogen. So I'm going to balance hydrogen first. So here you can see I have 3 hydrogen on this side and I have 2 on this side. So I can take the 2 here, put it as a superscript or as a coefficient here. I can take the 3 here, write it as a coefficient there. So now I have 2 times 3 is 6 hydrogen on this side, and I have 3 times 2 is 6 hydrogen on that side. So now my hydrogen is balanced, lead is still balanced, and so next is oxygen. So here you'll see that I have 1 oxygen here, but on this side I have 3 oxygens. So 3 times 1 is 3. And so I need to put a 3 coefficient here to balance the oxygen. So 3 times 1 is 3. 3 times 1 is 3. So the oxygens are balanced, but now I unbalanced the lead. So now I had to balance the lead. But luckily, I have lead by itself over here. So 3 times 1 is 3. So all I need to do is put a 3 coefficient there. And now the lead is balanced. So everything is balanced except for nitrogen. So now I got to double check to make sure nitrogen is balanced, and if not, I got to balance it. So here I have 2 nitrogen. 2 times 1 is 2. And then over here I have 1 times 2 nitrogen. So I have nitrogen balanced on both sides. So this is balanced. Everything is balanced. And you can double check to make sure everything's balanced. Okay, so next we have C. So here I have this reacting with water to form my phosphoric acid. Okay, so again, we're going to balance the metals first. We don't have any metals, so we're going to balance everything except for hydrogen and oxygen. We'll balance hydrogen before the oxygen. We'll save oxygen for last and see how that works. Okay, so here Phosphorus, I have 4 phosphorus on this side. 1 times 4 is 4. I have 1 phosphorus, 1 times 1 on this side, so I should put a 4 here. So now my phosphorus is balanced. So I have 4 and 4. So now next is going to be the hydrogen. So I have 2 hydrogen on this side. I have 4 times 3 is 12 on this side. So I need 12 on this side. So what times 2 is going to give me 12? 6. So I'm going to put a 6 in front of my water. So now my hydrogen is balanced. 6 times 2 is 12. 4 times 3 is 12. 4 times 1 is phosphorus, is 4 phosphorus. And then 1 times 4 is phosphorus. So my phosphorus and my hydrogen are balanced. Now I just need my oxygens. So on this side here, I have 10 total of phosphorus or oxygen. I have 6 times 1 is 6. So I have 6 there. So I have a total of 16 oxygen on this side. And I have 4 times 4, which is 16 on this side. So my oxygen is already balanced. So that's awesome. So everything is balanced. So I can move to the next one. So in this equation, I have metals. So I'm going to balance the metals first, and then I'm going to balance the non-metal. So I don't have this non-metal chlorine. So let's go ahead and balance. So here I have manganese, 1. I have 1 manganese here, and I have 1 manganese there. That's balanced. Here I have 1 chromium, and here I have 1 chromium. That's balanced. So now I got the chlorine. So here where I can use the subscripts and write them as coefficients for the opposite sides. So here I have a 2. So I'm going to write that as a 2 here. Here I have a 3. I'm going to write that as a 3 there. So now my chlorine is balanced. 2 times 3 is 6 chlorines. 3 times 2 is 6 chlorines. So now I have to go back and rebalance my metals because now my metals are imbalanced. But that's easy enough because I have my metals by themselves. So if I have 2 chlorines there or 2 chromiums here, then I would have 2 chromiums there. And if I have 3 manganese here, then I just put a 3 there. And now everything is balanced. Okay, let's go to the next one. Here we have a combustion reaction. So here we have acetylene reacting with oxygen to form carbon dioxide and water, a typical combustion reaction with a hydrocarbon. So again, we'll balance metals, but we don't have any metals. So here we're going to balance all the non-metals except for hydrogen, except for oxygen, because notice that oxygen is by itself. So I'm going to leave that for last, and I'm going to balance the carbon before the hydrogen. So carbon first, then hydrogen, then oxygen. So I have 2 carbons here. I only have 1 here. So 1 times 2 is 2. What times 1 gives me 2? 2. So 2 times 1 gives me 2. So now my carbons are balanced. Next for the hydrogen, I have 2 hydrogens here, and I have 2 hydrogens here. So 1 times 2 is 2. 1 times 2 is 2. So my hydrogens are already balanced. So next is oxygen. Oxygen is last. So I have 2 on this side. I have 2 times 2 is 4 from the carbon dioxide, plus 1 times 1 gives me 1. So I have a total of 5. So I have 5 oxygens on this side. I have 2 on this side. So what coefficient times 2 will give me 5? If you said 2.5, that is correct. So 2.5 or 5 halves would be the fraction. And so that balances my equation because now I have 5 oxygens on this side. 2 times 2.5 is 5. And then I have 4 plus 1 gives me 5. But I can't keep it this way. I have to get rid of the fraction. So to get rid of the fraction, I need to multiply by 2. If I do that, I need to multiply everything by 2. So 1 times 2 is 2 here. And then here, 5 halves times 2 is 5, or 2.5 times 2 is 5. So I'm going to put a 5 here. 2 times 2 is 4. So I'm going to put a 4 there. And 1 times 2 is 2. And then I can double check. So for the carbons, 2 times 2 is 4. 4 times 1 is 4. For the hydrogens, 2 times 2 is 4. And here I have 2 times 2 is 4. And then for the oxygens, I have 5 times 2 is 10. Here I have 4 times 2 is 8. 2 times 1 is 2. 2 and 8 is 10. So everything is balanced. Okay, 3 more to go. Okay, in this one we have some polyatomic ions and some metals. So we're going to balance the metals first. So I have 1 cobalt. 1 times 1 is 1. And here I have 1 times 3 is 3. I have 3 cobalts here. So what times 1 gives me 3? 3 times 1 gives me 3. So I have 3 cobalts now and 3 cobalts here. So that's balanced. Next, I have the sodium. So sodium, I have 3 sodiums here. I only have 1 sodium here, right? 1 times 3 is 3. 1 times 1 is 1. What times 1 will give me 3? 3 times 1 will give me 3. So there's the 3. And so now my sodium atoms are balanced. So 3 on this side. 1 times 3 is 3. 3 times 1 is 3. And so now all my metals are balanced. So now I'm going to balance the polyatomic ions. I'm going to treat each polyatomic ion as a unit. So here I have 3 times 2 is 6. So I have 6 nitrates. Over here, I only have 3 nitrates. 3 times 1. Don't multiply by that 3. That 3 is part of the formula for your nitrate. So I have 1 of these times 3. That's 3. So I got to change this to 6. Because 6 times 1 is 6. And here I have 3 times 2 is 6. So now my nitrates are balanced. However, my sodiums are now not balanced. So I have to come back here. And here I have a 3. So I need 6 on this side. So what times 3 gives me 6? 2. So 2 times 3 is 6. That gives me 6 and 6 for the sodium. Everything's good so far. Now I have phosphate. So here I have 2 times 1. Phosphate gives me 2. And here I have 1 times 2. Phosphates gives me 2. So now the phosphates are balanced. So I don't need to balance anything else. Now everything is balanced in my chemical equation. Next, we have CH3NH3 gas reacting with oxygen give you carbon dioxide, water, and nitrogen. Since I have nitrogen by itself, that means I'm going to leave this for last. So I'm going to balance everything else except for nitrogen. So I'm going to start with the carbon. I have 1 carbon on this side. I have 1 carbon on that side. So carbon is balanced. I don't need to do anything with that. Next is nitrogen. But nitrogen I'm leaving for last because I have nitrogen here. Hydrogen I'm going to balance. So here I have 3. Oops, this should be a 2. So I have 3 plus 2 is 5. So I have 5 on this side. Let me double check this for a moment. All right, yeah. So that is correct. So now in this case, notice that I have oxygen all by itself as well, but I also have nitrogen. So if I'm going to pick one of these, then I would leave oxygen for last first. So remember, oxygen is normally left for last if you can. So in this case, I will balance nitrogen first and leave oxygen for last. So here, nitrogen, I have 1 nitrogen here. 1 times 1 is 1. And then here I have 1 times 2 is 2. So I have 2 on this side, only 1. So I'm going to put a 2 there. Now notice that I have 2 carbons and I only have 1. So now I need to multiply this by 2 as well. So here I'll have 2 times 1 is 2, coefficient 2. 2 times 1 will give me 2 here. So now my carbons and my nitrogens are balanced. So now I can go on to the hydrogens here. I have 3 plus 2. I got 5 here if I multiply that by 2, because 2 times 3 is 6. And then 2 times 4 is 4. 6 and 4 is 10. So I have 10 hydrogens on this side, but I have 2 hydrogens here. So what times 2 is going to give me 10? 5. So I'm going to put a 5 here. So now I have 10 hydrogens on this side, and I have 10 hydrogens on this side. So now I have oxygen left. So oxygen is last. So now you'll notice I have 0. I have 2 on this side, but I have 2 times 2 is 4. 4 oxygens from the carbon dioxides, plus 5 times 1 is 5. So I have 5 from the water. That's going to give me 9. So I have 9 oxygens on this side, but I have 2. So my coefficient can be a fraction. What times 2 gives me 9? If you said 4.5, you're correct. Or 9 halves, you'd be correct. So 4.5 or 9 halves will give me a balanced equation. So the number of oxygens on both sides is now balanced. So everything's balanced, but I need to get rid of the fraction of a 0.5 or a half. I'm going to do that by multiplying everything by 2. So 2 times 2 is 4. Nine halves, or 4.5 times 2 is going to be 9. Two times 2 is 4 for the carbon dioxide. So I'm going to put 4. And then 2 times 5 is 10, so 10 waters. And then 2 times 1 is 2. So 2 there. So now I have a balanced equation for G. And now let's do the last one. So again, here you'll notice I have oxygen by itself. That's the only element I have by itself, so I'm going to save that for last. I'm balanced oxygen last. I have iron. Iron's a metal. I'm going to balance that first. It's the only metal I have. So here I have 1 times 1 is 1 iron. Here I have 1 times 2 is 2 irons. So on this side, I'm going to have a 2. So 2 times 1 gives me 2. So now I have 2 irons on both sides. So now, what's next? I have sulfur and hydrogen. So I'll do sulfur first. So sulfur is 1 here. I have 2 here. So 2 times 1 is 2. And sulfur over here, I have 1 times 1 is 2. So I have to put a 2 coefficient. So that 2 times 1 is 2. So I have 2 sulfurs on both sides. So now sulfur is balanced. And then next, we have hydrogen. So hydrogen, I have 2 hydrogens on this side. And over here, I have 2 times 2 is 4. So I'm going to have 2 times 2 to get 4 here. So 2 is put there. So now all of my elements are balanced except for oxygen. And so here, I have this element here plus these 2. So over here, I have a total of 4. So 2 plus 2 equals 4. And then on this side, I have 3. So 3 plus 2 times 4, right? 2 times 4 gives me 8. So on this side, I have 8. And that gives me 11. So I have 11 on this side, but I only have 4 on this side. So I need how many more? I need 7 more. So what times, so if I get rid of, so here I have a 2 on this side already here, right? So if I eliminate that from the 11, so then I need 9 more. So if I had 9 over here plus the 2, that would give me 11. So what times 2 is going to give me 9? So we get 4.5 again. So 4.5 or 9 halves, right? Multiplied by 2 gives me 9. 9 plus 2 is 11, so I've got my 11. It's balanced. But once again, I need to multiply by 2 to get rid of the 4.5 or 9 halves. But if I multiply this by 2, then I got to multiply everything by 2 to keep it balanced. And so that's what I'm going to do. So 2 times 2 is 4. And then here, 9 halves times 2, or 4.5 times 2 gives me 9. And then here, 2 times 2 is 4. And then here, 1 times 2 is 2. And then 2 times 2 is 4. And we can double check, right? So I have 4 irons. 4 times 1 is 4. 2 times 2 is 4. So irons are still balanced. Sulfur, I have 4 times 1 is 4. Over here, the sulfur, I have 2 times, oops, hold on a second. That should be 4. Let me double check. 4. And so this should be 4. Okay, let me double check. Yep, that's right. All right, so then 4 times 1 is 4. 4 times 1 is 4. So my sulfurs are balanced. And then here I have 9 times, well, we'll do the hydrogens first. So then here I have 4 times 2 is 8 hydrogen. And over here I have 4 times 2 is 8 hydrogen. And then the oxygens, I have 9 times 2 is 18, plus 4 times 1 is 4. So 4 plus 18 is 22. And then on this side, I have 2 times 3 is 6, plus, so I have 6 on this side, plus 4 times 4 is 16. 16 plus 6 is 22. So my oxygens are balanced. And so that, ladies and gentlemen, is how you go about balancing your chemical equations. I hope you enjoyed this video. If this was helpful in any way, then please, by all means, like the video, share the video, hit that like button. Also, make sure you subscribe to my channel, hit that notification bell, and when you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, or if there's a particular question or problem you want me to help you solve, I would love to do that for you. Thanks for joining me, and have a great day.